gosh. Adding, subtracting. Rationals. So if we looked at a basic fraction like we always do, and I have a half plus a quarter. With multiplication and division, it was great. We just went right away. Top, top, bottom, bottom, GCF, difference of squares, everything, right? Then canceled. But with fractions, when we add and subtract them, we need common denominators. This is true. The common denominator is often never smaller, it's larger, okay? So our denominator is 2 and 4. We're not going to divide the 4 by 2 to get 2, because then I get a half on the top of the fraction, which is really weird, right? So you multiply to get common denominators. We agree? So what's common to 2 and 4? 4. So the 4, we could multiply the top and the bottom by 1, technically, if we wanted to. Why are we multiplying the top and the bottom? Why? It's equivalent, just like we did before. It's equivalent. We're trying to make equivalent fractions that we can add together, correct? So when we make common denominators, we're trying to make equivalent fractions as to what the fraction you had before, just with a different denominator now, right? So we have to do it to the top and to the bottom. So do I have to go times 1 times 1? No, I could have left that one off. I'm just proving a point. And then this one I'm going to times by 2 and by 2. So I'm going to get this equal to 1 times 2, which is 2 over 4, plus 1 times 1, which is 1 over 4 times 1, which is 4. Then I get people saying 3 over 8. What was the point of getting a common denominator if you just add them now? You just add the numerators and keep the denominator, right? Because if you add the denominator, what the heck was the point of getting a common? Why wouldn't you just added it right away to begin with? Okay. So we're going to get 2 plus 1, which is 3 over 4. And we can only put them together once they have a common denominator. We agree? Okay. So what happens if I just have a number on the bottom? So I'm going to start off with a number in the bottom for my rationals, and then I'm going to have variables in the denominator. So first example. Let's say 2x, so we're going to say simplify. We're not saying solve. The reason why we're not saying solve is the moment you use solve, that means tell me what the variable equals, correct? Am I asking you at all to tell me what variables equal at this point? At any point in time, have I asked you to find out what your variable equals? No, that's going to be our last lesson. It's called solving. These are all simplifying, and how do you know what to do? You look for the operation between the two, okay? So simplify A. 2x over 3 minus x over 3. Why is this one nice? Because they already have a common denominator, and they have little monomials on top. So we're going to get it equal to 3 in the denominator because it's common, and then the top I have 2x minus x. What can I do then? Combine like terms in the numerator. What's 2x minus 1x? X over 3. And I'm done. Why don't I have to state non-permissible values? Because there is no, yeah, there's no variables in the bottom. It's just a number, right? So there's no way that the denominator can be 0. It's 3. It can never be 0. It's actually 3, right? It can't actually be anything but 3 because that's what it is. Selecting like terms, 2x minus 1x. Okay, B, try this one out. 2a minus 3 over 5 plus 9a plus 1 over 5 So what's good about this question? So we can write the whole thing over 5. And then we're just going to go 2a minus 3 plus 9a plus 1. We agree? Now we can go back to grade 9. Do you remember when your teachers would like circle the like terms, then triangle the other like terms, and then you'd put them together? We just didn't have a denominator back then. We just have a denominator, but once we don't have to really deal with it, right? It's just common. We write it, and then we just do grade 9 and 8 circles and triangles. Okay? So now we collect like terms. So we're going to go 2a plus 9a is 11a. I totally did not pick the smallest. No. And then I'm going to do circles. These ones are like terms because they don't have variables. Negative 3 plus 1, negative 2 all over 5. Do I need non-permissible values? No, because I don't even have a variable in my denominator. So these have not been too bad. The first one, not bad because it was just a monomial minus a monomial. The second one, not bad because there's an addition sign between two binomials, okay? The third one we're going to do is common denominator, but we're going to do subtraction with binomials. Let's see what we get. So we have C is 5y minus 1 over 6 minus 4y plus 7 over 6. So you were taught this in polynomials starting at least for sure in grade 9. We big time went over them in grade 10, and they've come through the whole time. Now, the catch here is when I have a plus sign in between, I could technically have went like this. 2a minus 3 plus 9a plus 1. And then I would distribute a positive 1 in, correct? But would that have changed anything? No. So I didn't put a bracket because that wouldn't change diddly squat, okay? But when it's a minus sign, what do I have to remember to do? Distribute it, because you are minusing everything behind it, are you not? So I have to remember to minus the 4y, but I also have to remember to also minus the 7. Do you think they're going to have the answer on your diploma where you forget to minus the 7? Yeah, absolutely they will. So we always have to make sure we know everything 100%, not even 95, because then you might fall to an error. Okay? So we can write it all over 6 because we have a common denominator. And then in the top, I don't try and collect like terms right now. I just write them back out. So I'm going to get 5y minus 1. And then I have to remember to minus this entire thing that's behind it, correct? So I'm going to subtract 4y, and then I'm going to subtract 7. We agree? Instead of just accidentally subtracting the 4y and not the 7, because that's not at all what it's asking us to do. So do you see how that's a common error people could do? If you're someone who's like, yeah, that's totally something I would do, I would leave a little star beside it, or a big star if you know you're for sure going to do it, and I'd say, remember to distribute that minus sign in, because that is ultimate common error. Okay? If you know that's you, you leave yourself a little note. Say, don't forget to distribute when there's a minus sign between. So when subtracting rationals, that's our common error, is that forgetting to distribute. Okay, now we can collect like term. 5y minus 4y is y. Minus 1 minus 7 is negative 8. So if you forgot to distribute it, you're going to have a 6 here, correct? You possibly not even notice you made a mistake. And then it's all over 6. Still no problem with NPVs because we still don't have variables in our denominator. Okay? So what would be the next step? The first step here, I gave you common denominators, and we practiced how to do stuff with enumerators, right? So we get that clear. What do you think the next thing might be? Not having that will be the next thing after that. There's one step before even NPVs. We can have not common denominators with just numbers, right? Still no variables in the denominator. So we're going to do that next. So D, we're going to simplify a lot of questions today. 3a minus 1 over 3 plus 4a plus 5 all over 6. What's our initial problem? We don't have a common denominator and we have a plus sign, correct? When we have a plus sign, we have to have a common denominator. So what's common to 3 and 6? 6. So I could multiply this one by 1 if I wanted to, correct? But I don't need to. And I'm going to multiply this side by 2. So what I'm going to do is I'm going to go 2 out like this. And then I'm going to remember to put this in brackets. So I remember to actually multiply all of it by 2, right? And then a 2 down here. So on the top, we're going to get 6a minus 2 all over 6 plus 4a plus 5 all over 6. And most of you guys have it sitting like this. What I would like to see is, hey, this rational is equal to this one, is it not? I like to see equal signs, not just random rationals floating down the page. Now, once we distribute that 2 through, we're right back to all the previous questions we were doing, correct? Not too bad. So we're going to go equal to all over 6. And we just write our numerator out. 6a minus 2 plus 4a. And I distribute the plus in. Plus the plus 5 is still plus 5, right? The addition ones don't change anything. It's when it's subtraction that it does. Then what do we do last? Collect like terms. So we're going to go 6a plus 4a, which is 10a, minus 2 plus 5 plus 3 all over 6. Still no non-permissible values, right? So I'm going to get you to try one on your own, see how you do. Yeah. Yeah. Now we're moving into NPVs. So this one is E. 8y minus 3 over 8 minus 2y plus 1 all over 3. What's common to 8 and to 3? 24. So you're going to have to multiply the 8 one by 3's and the 3 by 8's. It's okay if you have to do both. So try it out. So we're going to do that first before we even try and do the subtraction. So common denominator is 24. Multiply by 3 and by 3 and by 8 and by 8. And so I get 24y minus 9 over 24 minus 16y plus 8 over 24. And now they can be all written over 24. And then I get 24y minus 9 minus 16y minus 8. And so I'm left with 24y minus 16y is 8y. Minus 9 minus 8 is minus 17 over 24. Still no non-permissible values. So that's where we're going from here. Okay, what if we have basic monomials in the denominator? This F, lost my thoughts. Okay, F. So now we're going to do 5 over 3p plus 2 over 7p. Okay, the key thing here is we need to decide, are the 3p and 7p attached by plus or minus signs? No. So do they go in their own separate brackets or one whole bracket? Separate brackets. So we're going to do that first. By putting your denominator in proper brackets, it will help you for common denominators. So we're going to go 3p, 7p. So what do they currently both have in common? 21, but what do they currently have in common right now? P. They both have a P. So do I need to multiply them by a P? No, they both have a P. What's the problem? The 3 and the 7. I need to make those the same. What can I make them both be? 21. So I can multiply this side by 7. I don't know why I put this line there. 7. And this side by 7. And this side by 3. And this side by 3. When you're done multiplying, you should have the same common denominators. If you don't, you messed up. Try again. Okay? So on the top, I'm going to get 35 over 21p plus 6 over 21p. And so they're completely over 21. And then 35 plus 6 is 41. Now this time is the only time I've had to do this. What do I have to do? P cannot equal 0. You try G. I'm going to try these two. Why? Oh, I have it frozen. That's why. Oh, it's back. Okay. So 3y and 5. What's common to 3y and 5? What's common to 3 and 5? 15. And then we need a y, right? Because we have a 3, we have a y, we have a 5. So I can multiply, if you're not sure, multiply this side by 3, multiply this side by 5, and then you're like, okay, this one is 15y and this one is 15. Uh-oh. So this one here, I'd have to multiply by y as well. So I'm going to get 5 over 15y plus 18y over 15y. Then I would write it as 5 plus 18y over 15y, just like we did before. And then I would triangle the 18y. Is there anything else that's 18y? Is there anything else with a y? No. Okay, crap. It's by itself. I don't do anything with it. And then I circle the 5. Is there anything that doesn't have a variable? No. So actually, I just ruined my answer. I'm just going to rewrite it. So it's just 18y plus 5 over 15y. You can't put them together. They're not like terms. Y cannot equal 0. Okay, H. We have a 6. We have an X. We have a 3. We have an X. At least they both have X's. What common could I make them be? 6x. So I don't actually have to do anything to this side. I just need to multiply this side by 2. So I'm going to get 2x minus 5 over 6x minus 6x minus 4 over 6x. And so it equals 2x minus 5. And then I have to subtract the 6x. And then I have to subtract a negative 4. So it's actually a pop. All right. Oopsies. So 2x minus 6x is negative 4x. Negative 5 plus 4 is minus 1. Can I collect anything else there? No, I already collected everything. Over 6x. And then I have a 6 and an x by itself in the denominator, so x cannot equal 0. One last question. A plus 7 over 2a squared. Remember 2a squared, what does a squared just mean? So a times, nope, a times a. A times 2 is not the same as 2a's. Okay, the common denominator is 10a squared. So this one we need to multiply by a 5. Shh. So you guys can check your work. 2a. And so you're left with 5a plus 35 over 10a squared minus 6a over 10a squared. 5a plus 35 minus 6a over 10a squared. I feel like I need to like throw you back your lung every time. Here you go. No, that's not good. And then we collect like terms. 5a minus 6a is negative a plus 35 all over 10a squared. A cannot equal 0.